calculation. Nothing is here called as the prediction. Okay, prediction we'll do in the machine learning. Don't worry. Whatever the calculations are going to do here, solid calculations. You can make claims on that calculation. And that's how the world is running. You guys know that election fever is running here, right? Going on. So you guys also know that every election party has their own data scientist or data analyst, to be very honest. Okay? Because I have seen some of my friends, they are working for the team. What they do, they try to collect the data and they try to find the insights of the data, right? Basically what they are doing, they are just following the previous patterns. They are checking that from what area, what number of votes are going to come and how many numbers are going to come for our party. Okay, how we can make such predictions? You can also find the average number of voters from some particular area, even if the data is very huge. You can also find average number of voters from particular area for that particular party as well. Those all comes under the section of statistics. So statistic is nothing but one mathematical calculation. So statistic is nothing but one mathematical kind of a calculation. Yes, inferential statistics includes the population sample concept. Okay, claims you can say, predictions. Chalo, we'll talk about that. Don't worry. People misunderstood these terms. Okay, so no problem. Mathematical calculation. Okay, we are going to do some mathematical calculation on the data. We'll come to the solid proof of the answer and we can make claims on the data set for the related business question. And as I told you yesterday, guys, data science is not about learning Python programming language or Power BI or SQL or any of these things, machine learning. Data science is usually comes with problem solving. How quickly, efficiently, while gathering the knowledge of domain, you solve the business issues or questions. How creative you are. Okay, so understanding these statistical terms are going to be very important because the case study, most of the case study which you guys are going to solve while becoming the analyst or scientist falls under the category of statistics only. Okay. Now, if you guys want to know the definition, you can pick the definition from the PDF. I'm not going in that direction. We have to understand this very carefully. Statistics comes with two branches, okay, or two types. The first one is your descriptive. The second one is your inferential. Okay. Descriptive means what? As per the name suggests, we are going to describe the data set. We are going to go deep inside the data set and try to understand that. Whereas inferential comes for the data when it is large in quantity or huge in quantity. This is for large data set and this is for small population or small data set. Okay. Now, since we are talking about descriptive and inferential, let's understand one more thing that what descriptive is, what inferential is, with the help of an example. Okay. What example I am talking about? Consider, yes, those who are taking second time the class, I am giving the same example. Okay. So the question says that here, sorry for that, guys. Yeah, coming back to the point, we were talking about this descriptive and inferential statistic. Let's understand this thing with the help of example. Okay. I know this starts a bit boring in the start, okay? Because you have to understand these terminologies. Once you will jump into the deep of statistics, now you will find it very fun. So please bear with me, understand these particular concepts, okay? Descriptor statistics say that I am planning of gifting you guys some t-shirts. Okay, right now I can see we are having 18 in the session. Okay, and 18 of you I thought of giving you is a t-shirt. So now guys, you can see point number 1, the data is small. The population is small. What is population? We'll come back to that point, okay? Don't worry. When we talk about population means what? It is your overall data set from which you want to extract the information. Population, let's say if I ask you to find the average height of class 8 students. So, do you guys know in your area how many class 8 students live? In your city, how many class 8 students live? No. So, your whole city with class 8 student is going to be a population. Okay, so population is something which captures your overall data based on the question. Overall data. Let's say if I ask you to find the average sales of tea leaves. Okay, so do you guys remember what, well, let's say what particular house is purchasing what amount of tea leaves? No. So whole city is going to be your population, right? And the population is something which consists the information for us to calculate or to find the observations in near future. Okay, so when I am talking about gifting t-shirts to you guys, what is the number of my population here? 18. You guys are 18 in the session. So this is my population. I have to give you guys t-shirt, one of you each. Now guys, understand that my pocket is very small. Okay, I'm not very deep pocket person. I have to give you guys one similar size of t-shirt. Okay, because I cannot afford to go each one of you and capture your size. And since we cannot capture the size, I cannot give you the t-shirt, right, of your own choices. Oh, so sorry for that, guys. Very distracted today. Yes, I was talking about gifting you guys a t-shirt. Okay. Now what happened, I told you, I cannot go and ask each one of you what is the size of the t-shirt, right? It is going to be again very lengthy process and not a pocket friendly approach for me. So what I have done, I asked your size, I asked you to fill one form and in the form you guys fill your sizes. Since you guys filled your sizes, I found one average size of a t-shirt and I thought that I'm going to give that average size of t-shirt to whole 18 population. So that is descriptor statistics. Descriptor statistics tells us that every data point is going to perform in my calculation. We were having 18 entries there. Every 18 entry filled the form, mentioned their sizes, and on the basis of their sizes, I am making one average calculation of the size and giving you guys a t-shirt. Okay, job is done. The pocket is very safe. You guys are also happy. You receive the t-shirt. Okay, now let's hop into the inferential statistics. If I say that the population is unknown here, okay, when I'm saying population is unknown means what? Population could be any number. Let's say, for example, I'm planning to gift a t-shirt to whole city. Okay, now I don't know how many people are student there, how many people are working, how many people are thin, how many of them are fat, how many are outdated, how many are very short. I don't have the calculation of those data. Okay, since I'm not having the calculation of such entries, I say that my population is very unknown to me. And the population is very large as well. Okay, since the population is very large, where I cannot perform the descriptive statistics solely, what I do, I take the help of inferential statistics. Once in the inferential statistic, let's say the population here is huge, okay, and unknown as well. Okay, we also call this as countable infinite. Okay, of course we can count it, but it is infinite. This is countable finite. Let me write it down. Okay, this will give you the better understanding. This is countable finite. We'll go in deep, okay, later. But as of now, understand this is countable finite and this is countable infinite. What is countable infinite? Let's say, yes, you can count it. Let's say if I ask you to count the number of population for an hour, you can give me one figure, okay? But it is that huge in nature, we cannot reach to the exact answer for whole population. It is countable infinite. Yes, it is countable for a certain moment of time. We can give you some number. If I keep on counting for, let's say, 30 minutes or an hour, it is countable. The population is that huge, we say that we cannot reach to the exact population number. Okay, so this is countable finite. You can see we are counting it, and it is finite in nature. We will, by the end of the calculation, will reach to some goal. Here, by the end of the calculation or counting, I don't think we are going to reach some goal. But within half an hour or 2 hours, if I give you, you will definitely give me some number. But I don't know how many population are there and how much time it is going to take for you guys to give me the exact population number. So that is countable infinite. So since the data set is large, what I'm going to do, the concept of population and sample comes into the picture. Previously, only we were working with the population. Since the data was small, we were working with the population, we were happy. Now here, this sample and population concept come into the picture. Okay. What is population? Here the population is this, countable infinite in nature. I'm simply writing CI representing countable infinite. Now I am drawing one sample from this population, and the sample size could be anything depending upon the test we are applying, depending upon the type of approach we are taking. The sample size is going to depend on it. Okay. So let's pick up the medicine batch example. Okay. Since I am going to, let's take the example of medicine batches. Okay. You guys consume medicines. There is very countable infinite. Let me write it down. Okay. I thought it is countable infinite. The population is countable infinite. Okay. And from this countable infinite type population, I am drawing the sample. Okay. Now consider the example of medicine batches. Okay. Medicine batches, you guys know, they make medicine, very huge amount of medicine for each batch. Right. Now, since the medicine batches are there, I want to check the drug composition of medicine present in that particular batch. Let's say in batch, we are making some crores of medicine. Okay. But I want to check the drug composition, and then I'm going to sell it to the stores, or let's say pharmaceutical stores. Okay. So since you guys are going to pick up the whole batch, whole crore of medicine and check their drug composition, no. You're going to draw this sample, because you guys know that the population they made all together, right? So if I'm going to pick up the sample and I'm going to check the composition inside the sample, that is going to be the composition of whole population. That is the concept of population sample technique in inferential statistics. My data is huge. Let's say crore of medicines are there. I have to check the composition of those tablets one by one. So what I'm going to do, I'm going to check, let's say, every packet of medicine, I'm going to pull out one medicine and check it. No, it is going to destroy the packaging as well, right? We don't have that much of leverage of money or time. So what we are going to do, from that batch of medicine, that's why they say every time, if you look into the medicine, there is something written called as batch number, right? So from that batch number, I'm going to pick out one sample of the medicine, or let's say multiple samples of the medicine from multiple corners of the tree, and I'm going to check their drug composition. Whatever the drug composition of sample is, I'm going to say that it is the similar drug composition for the population. You can also say that when we draw the sample from the population, we can apply descriptive statistics on the sample, make some claims, and say that the claim for the sample is similar to that of the population. Getting it? So yes, we are drawing the sample because we cannot apply descriptive statistics over whole population, which is countable infinite in nature, right? Don't worry, we'll cover everything in the testing types of statistics, okay? One by one. We are getting the rough idea what actually it is. Once we'll hop into the different type of tests, then you will see that what population, what type of samples we are drawing, is every sample participating or not, or we are having any sort of errors, okay? Those things. So coming back to the point, this is population and sample technique. In the sample, you are finding the descriptive stats, pulling it back to the population, stating that whatever the calculation for the sample, it is same as that for the population. Understand that, guys, descriptive statistics is very easy to understand. You guys will understand within few minutes. But what about inferential? It contains so many different bifurcations within it. Okay, now let's talk about what all tests and what all parameters of statistics comes under the descriptive and inferential. Since we are talking about the descriptive statistics, we are having measure of central tendency, and second one is measure of spread. Okay, these are two bifurcation of descriptive statistics. In a measure of central tendency, we have, let's say, mean, mode, median, these three things. And in measure of spread, we have standard deviation, variance, range, interval. So, guys, understand that we are having two branches of error. We are having two branches of descriptive statistics. Inside the two branches, we are having statistic parameters. Okay, so understand that these two are statistical parameters. What are these two? Statistical. Why I'm spoon feeding you guys? Because I know there are too many technical terms and you guys are going to forget once we hop into the testings. Okay, so whenever I say parameters, which means I'm talking about this, not this measure of central tendency and measure of spread. No, I'm talking about these two parameters. Okay, inside the descriptive statistics. Getting it? Any questions still here? What about new people? Are we good till here, guys? Information that you guys are not sleeping. What I call these are statistical parameters. What are the parameters, guys? Basic language in let's say English. Parameters are something which helps us to check the statistics, right? The statistical parameters, but it is falling under the category of descriptive. Simple. Shall we move forward to the inferential one, as I've seen already? Now, how to perform inferential statistics? Because I told you it is the concept of the population sample. And we are going to pick up the sample, applying the descriptive statistics on the sample. Then we'll say the calculation for the sample is same as that of the population, right? So how we are going to perform inferential stats? So inside the inferential stats, we are having different types of subdivisions. What are the subdivisions? The first subdivision, the second subdivision, the third subdivision, right? And the fourth subdivision. These are very important, guys. You will understand above descriptive statistical parameters very easily because those are completely based on the calculation of formula. There is inferential one based on the probability. Okay. So the first one is your confidence interval. Let me write it down. Okay. I'll enhance the size. Wait for a minute. The second one is your central limit theorem. The third one is hypothesis testing. And the fourth one is regression analysis. Okay, let me increase the size. Okay, so these are the 4 different branches of the inferential statistics. Now again, in the hypothesis testing, we are having different type of tests. You can say first one is your Z-test. The second one is your T-test. Third one is your chi-square. Fourth one is your Z-T chi-square. Okay, so these 4 are different type of tests falling under the section of the hypothesis testing. And later, these are the independent, we can say, terms. Confidence interval is independent topic. This is independent. Testing, we are having 4 different, and regression analysis is again the independent topic. So above ones are the statistical parameters. These are not guys, okay? These are some theorems and tactics which we are going to use for saying that the sample is equals to the population. Okay. And please remember this table because you shouldn't be, let's say, sitting blank if I'm going to pick up the topics from here. I cannot create the table or let's say the hierarchy every day, right? So jot it down or remind this, take a screenshot, do whatever you want to. If I'm going to pick up the bifurcations, you have to understand that it is the part of descriptive, this is the part of inferential, and we have to think in that approach. Okay. So what we are doing, we are trying to recollect the contents of the statistic so that once we hop into the statistic and try to do some test and analysis, you won't be confused, right? What is the foundation of these concepts? So these are the foundations. Now we are going to talk about distributions. Okay, so before jumping into the distributions, let's talk about variables. When I say variables, variables means what? We are talking about your columns. Okay, if you guys remember, recently I have given you one loan data set, right? So in that loan data set, you guys must be watching that there were different type of columns present, right? Though we were having 2 different types of columns. The first one was numerical. In the numerical column, you guys have seen that we were having float 64, integer 64 type of data. Okay. Now the second one was object type of data, and we call those type as categorical feature. And now, since you guys have completed plotting, I am giving you the better clarity that you cannot apply the similar test which you are doing for the numerical to the categorical, right? Categorical contains your different type of values, whereas numerical contain a different type of values. In the numerical section, you guys have also seen that again we are having two bifurcations. The continuous type of data and the discrete type of data. Guys, please don't draw, okay? Although I have stopped the editing part, but I don't know still why it is happening. Discrete. Okay, so continuous and discrete are again two bifurcations of the numerical. For categorical, we have again three bifurcation. Oh, sorry, two. Nominal and ordinal. Okay, so you can see variables means the columns. Column has two different data types, numerical and categorical. In the numerical, we again have two bifurcation, continuous and discrete. And for categorical, we have two bifurcation, nominal and ordinal. When the correct time comes, we'll have the discussion over these two. Right now, yesterday, we already had the discussion over these two. Right? Let me give you one example, guys. You have to judge. Is it a continuous type of data or the discrete? Okay, shall we do that? Are we ready? I'm going to say one statement and you have to judge. Is it a continuous numerical type of variable or discrete numerical type of variable? Okay. Now, the question says that the speed of the vehicle within an hour, is it a continuous data or a discrete data? First की जवाब देना, okay? Think and then answer. The speed of the vehicle for an hour. What do you guys think? If you guys start the vehicle, you give accelerator in the constant manner. Let's say I started riding my bike. I accelerated in 40 kilometers per hour per second to the 60, let's say, whatever the seconds required to complete an hour. Are we going to do that? Your speed are going to fluctuate, right? Based on your accelerator. So it is continuous type of data. Speed of a vehicle. If I'm going to say 40 kilometers per hour, then it is going to be discrete value because it is not changing. Speed of the vehicle within an hour, you will see the fluctuations in the speed. Maybe you started from 10, 20, later you accelerated till 30, 40, and then there is some constant acceleration. Now you want to stop the bike, then you will lower down your accelerator and then reach to zero again. Continuous type of data. Okay. Now number of two different type of fruits in two separate basket. What is it? Number of two different type of fruits in two different baskets. Discrete, right? Because the number of fruits are not going to change unless you are going to participate in that, let's say, changing manner. Okay, the continuous is something the values are changing over the period of time. Discrete is something the value is remaining constant. Okay, let's say the number of fruits in a basket, number of eggs in a basket. These all are discrete type of data. Whereas continuous, the loan amount, the applicant income, these values are getting changed from every observation to every observation. Okay. Whereas if you guys can see, the credit history is also one column, contains 0 and 1 type of credit. Discrete. Okay, so in the numerical, we have two different type of values and this are the two different type of values. Now, why we are having discussion over this? What is the purpose? Based on these two different type of values, we are having the distribution in the data set. Okay, for categorical features, we have some different type of distribution. For numerical continuous, we have some different type of distributions. Okay. Now, one more question to you guys. One more question. When we were plotting the continuous data yesterday with the help of KDE, kernel density estimate graph, what was the function present in the y-axis? There was some function present in the y-axis, right? If you guys remember.
Probability.
Yes, that is PDF. Okay, yes. The PDF function was there. So the function will change. Okay, we have PMF also, we have CDF also. Cumulative density function, probability mass function. We'll cover all of them. Okay, just give me a moment. Presentation of variable. Coming back to the point now, since we are talking about continuous and discrete type of distributions, let me give you the heading of distribution based on this numerical data. You also understand one thing, right? Distribution we can only do for numerical type of data, not for the categorical one. Understand this thing very carefully. Different type of distributions. Let's write the different type of distribution first, and then we will talk about how these distributions are correlated with the different sections of the statistics. Okay. The distribution for continuous type of data. Distribution for discrete type of data. Okay. So for continuous we have, I'm writing it down, normal distribution. That's what we were talking about yesterday. But we will see this distribution in a bit more depth. The second distribution is t-distribution. The third one is chi-square distribution. And the fourth one is exponential. Okay, let me. This is for continuous. Let's make discrete bit R. Let's write discrete type of distribution. We have Bernoulli's. OU. Bernoulli, binomial, uniform, and Poisson. Okay, so these four type of distribution falls under the discrete category. Based on the different. Hey guys, can you see this bifurcation? Is it visible? Move your whiteboard. Maybe you might have missed it. Just try to move your whiteboard. You might scroll it down accidentally. Okay, coming back to the distribution section, guys. See, this is continuous and this is discrete. Okay, normal distribution, t-distribution, chi-square, and exponential. Discrete, Bernoulli, binomial, uniform, and Poisson. Now understand why we are talking about this distribution. Oh, this is relevant to the different branch of statistics. Now we were talking about the descriptive statistics and the inferential one. Okay? Now what will happen in that case? A descriptive statistic works with the continuous type of values, numerical again. Okay. You are going to plot the normal distribution and, or let's say any continuous distribution. I'm going to find these statistical parameters for that distribution. Also, since it is following the normal distribution or any type of distribution in the continuous, and we know the combination of inferential statistic with the descriptive one, these all tests also going to work with the continuous type of data or mostly with normal distribution. Normal distribution is very important, guys. Of course, we are going to see different type of distribution, but this distribution is going to cover all these statistical bifurcations which we have done for inferential and descriptive. Okay, so we will understand what is normal distribution, what is standard normal distribution. These all tests are independent. They all are independent and they have no dedication, let's say no contribution towards this inferential or descriptive testings. Okay, But normal distribution, it has. So we are going to focus more on that normal distribution direction, and we will cover rest of the distributions later. One. Okay, that's why we were talking about the distributions. Getting it? Any questions here? Then could you please tell me if we roll a dice, is it a discrete outcome or continuous one? Think and then answer, okay? Rolling a dice, is it a discrete type of outcome or a continuous? Discrete, okay? It is discrete type of outcome, rolling a dice. Because you guys know that only some of the values are going to come, which is 1, 2, 3, 4, 5, 6, right? Also, picking a card is again discrete type of value. Whereas time, distance, speed, these all are continuous. Right, good.
But if we roll a dice, let's say 100 times, then it would be, I think, continuous, right?
No. Do you understand the nature of the data? If you roll a die, let's say 100 times, still you are going to get the numbers out of those 6 numbers, right? Either 1, 2, 3. So we are going to have repetitive values. But in the continuity, have repetitive values. Okay. And today, the topic of today is normal distribution. First, we will understand normal distribution. Then we will hop to the descriptive statistics and inferential statistics. Later, once cover all of those, then we will hop back again here and cover rest of the distribution. So that's how this part of statistics will go. And guys, if you understood this part, your 80% of statistics is over. Okay. The rest of them are, let's say, exploratory data analysis, linear algebra, rest of the basic stats, you can say. Okay. Plotting, so we have already done. Understanding the graph is point number 1 for instance. Okay. We cannot work with normal distribution with discrete data. Wow, wow, wow. Kya question hai? This is a very good question. Okay. Now this is going to be answered for everyone. Why cannot we have normal distribution for discrete type of data? What is discrete type of data? Data which is repetitive in nature. Understood? Now, since we are having, let's say, 3 different values, 1, 2, and 3, and these are getting repeated. These are coming 40 times, this is coming 60 times, and this is coming 70 times. Okay? If we try to plot the graph in the normal distribution, you will see only 3 entries here. 1, 2, and 3. Even if you try to plot the probability density function, do you understand the probability of this and probability of this and probability of this will be one value. Let's say I'm writing 0.02. This is 0.03 and this is 0.04. Okay. So we are having the things like this. We are having 1 here. We are having 1 dot here and we are having another dot here. Is it creating any sort of graph for us, guys? No. Okay. That's why we cannot perform these statistics. Yes, we use bar graph. Don't worry. Okay. But there are some of the things. Yeah, it will not help you to understand the spread correctly. And for discrete, we don't have PDF. We have PMF, probability mass function. You can see we are carrying the mass of every value, right? So there you will see the graph. So don't worry. For continuous, we have probability density function, normal distribution. For discrete type of values, we have probability mass function. Okay. Don't worry. Bar graphs and everything we use for categorical feature. For discrete numerical, we have other terminologies. Wait, I'll be back. See, it will not help you to understand the spread correctly. Its distribution is mostly used with discrete type of value. See, the discrete type of value also contains line graph, but here the function will get changed. Okay, that's what I'm talking about. Right now it is probability density function. We are checking the density, right? There it will be probability mass function. Okay, we'll talk about this. Usually we create histograms here in the discrete one. Okay, and here in the continuous one, we create line graphs. Now am I making sense? Because in the discrete values, there is something called as frequency always comes into the picture. But in the continuous feature, we don't have frequency because the data is not getting repeated, right? So usually we create histogram for discrete type of values. For continuous, we create line graphs. Yes, that is true. Okay. Or kuch? You need to understand this on the data set point of view. Okay. What is the mean for the data set? What is the median for the data set? What is the downward distribution for the data set? No. So first of all, let's understand probability density function. Guys, do you understand what we are picking right now? We are picking, first, let me bifurcate it for you. Okay. We are talking about the mean distribution, right? Distribution is normal. Now it is, when I ask you for what kind of values we do normal distribution. So the point number one you guys have to say is continuous numerical type of variable. That's why I've given you the table, okay, or the bifurcation. Continuous numerical variable. And this is how you will see. If you open any statistic book, okay, this is how you will see. This is the plot which we create for continuous numerical types of variable, where in your x-axis you will be having your column, and in y-axis what is going to be the probability density function. Okay, what type of graph we are creating? Kernel density estimate. Okay, now you can see continuous probability density or probability density function. An expression which is used to define the range of values. That's what I told you, right? 0 to 1000 range, 1000 to 2000 range, 2000 to 3000 range. That is a continuous random variable can take. Okay, so you can also pick random here, or let's say write random. Anybody needs the explanation of random? What is random or what is randomness? It's very easy, guys. Randomness is picking up randomly something. Suppose you are having bag of different color balls. If I ask you to randomly pick 3 balls without looking into the bag, you're going to put your hand inside the bag, you'll pick out the ball, and that is the random outcome. Okay. So what is random outcome? Without making any decision from the brain, you are randomly picking something. That is randomness. Whenever your brain and decision making comes into the picture, randomness it is not like that. Okay. Randomness is always picking something randomly without watching or without looking into it. Okay. So yeah. Looking into the probability density function definition, what it is say? An expression which is used to define the range of values. Okay. Range of values, as I told you, because we are talking about continuous. Okay. Still somebody have any sort of issue understanding continuous data? You guys can let me know. You need to have a proper, let's say, clarity in your mind for continuous and discrete. Okay. Abhi bol rahi hu main. If you guys are facing challenges, let me know right now, because I don't want you to sit blankly or wondering what is happening. Continuity means what, guys? In your every observation, the data is getting changed. Okay, simple. If you don't want to use that much brain to understand it, We can simply say that in every entry or in every row, my values are numerical and getting changed, unique. Okay. The probability density function says that when we have continuous random variables, okay, so what we do, we try to pick up the range for that continuous random variables. What are the range I'm talking about? Consider, okay, consider 500 people and they are running a marathon. Okay, that's what happened in big cities. They run a marathon on weekends. So 500 different people running a marathon. Now somebody, let's say, came to me and they asked me a question. What is the average speed of people running the marathon? Getting it? Getting it? Let me repeat the question again and then you have to tell me what approach should I give. Okay. Now I have 500 people. They all are running a marathon. We understand that it is continuous type of data if I'm going to measure their speeds. Okay. Also, they came to me and asked me the question, find the average speed of the people running a marathon. Okay. What do you guys think? What approach should I give? Discrete approach or inferential approach? The question number 1. Shall I give the discrete approach or the inferential one? If 500 people running the marathon, a discrete approach or inferential approach. Inferential? Why inferential? 500 लोग दौड़ रहे हैं, क्या मैं discrete approach नहीं दे सकती? What do you guys think? 500 is not a countable value, क्या? Can I'm not saying that I'm going to go and check their speed. No. Can I give this a discrete approach? Measure of their dispersion, what is their average rate of running, all of that. Can I capture that value? I'm going to give form to those 500 people. I'll ask them to fill the form. What is the average speed you guys are running with? Easy. This is descriptive approach. Okay. Inferential means what? I will tell you. This is not in inferential. You will not have the population value. Here I'm giving you the population value. What is the population value? 500. Right? Whenever you are having the value of population, understand that this is discrete approach. In the inferential approach, you won't even know the value of population.
But Megha, how can I get the average of 500 people, speed of 500 people?
Okay, this is the question, right? That is why we are learning standard normal distribution. Wait for a while, you will understand with the time. But how can we judge it with the help of discrete statistics? So understand this thing. We are going to give discrete approach, okay? Those who are thinking on equation, remove it from your brain right now. This is discrete approach. We are having the population as 500. Okay, countable finite. Now, what is probability density function? Now, when this is discrete approach, whatever type of approach it is, I don't care because we are talking about distribution. Whenever we are picking any type of approach, what it is trying to say, probability density function try to define the range of values. Getting it? Now understand this thing very carefully, guys. I'm giving it to you. Understand it. We are having 500 people. Now people are running from some speed, average speed. I have given them forms. They fill out their average speed. Do you understand that? The speed of one person, there is a possibility might match with some points to the speed of another person. So I filled out the form as 5.6 km per hour is my speed. And somebody else filled 4.9 km per hour is my speed. They are getting the values close, although they are continuous. Okay. They are different from each other, but they are close, right? So probability density function cannot plot the every unique type of value one by one. So what it does, it merges them up within some range and find the probability of it. What will happen? Now remember the case, okay? I am running with 5.3 km per hour. Somebody is running with 4.9 km per hour. The range which we are picking for first probability count is 5 km per hour. So what I'm going to do, I'm going to find the probability of person 1 with 5 km per hour, probability of person 2 with 5 km per hour within that desired range, 0 to 5 kilometer range. Then again, I'm going to pick 5 to 10 kilometer range and identify the probability of those persons who are falling in that category. Then I'm going to pick up another range, identify the probability of those people falling under that range. Okay, so I cannot plot the continuous value one by one. That's why I take the help of probability density function so that it will give me the bell-shaped curve. Now understanding the point, what actually it is. Example, if you can see the gate, the risk reward of a stock. Do you understand the stock market? What it is? Every time you see the price of stock getting fluctuated, right? So am I going to mark out every time the 0.1 paisa change, 0.2 paisa changes on the stock? I cannot. So I am going to take up the range of let's say 10 paisa change, right? I'm going to create a lot between them. I'm going to pick up the range. Instead of marking every second moment change in the data set, I'm going to pick up the range and mark the values down. That is what probability density function says. Getting it? Understanding the idea, what it is, why it is getting used in the continuous values? Am I making sense, guys? So probability density function defines the range, defines the probability of the value within that particular range. Okay. Now let's say, a core example, last example, okay, I'm not going to burden you today. Last example to understand probability density function, okay. Now me, Jimit, Vinay, and let's say, Arti, we four are there, okay, and we all are running with a speed of, let's say, I am with 4, Jimit with 5, Vinay with 4.9, Arti with 4.5. This is our range of speed. The probability density function will do what with it? It will pick up the range from 0 to 5 because we need to have some average range value for that. And it will try to calculate the probability of our speed for that range so that my plotting can come within the desired range. Because we cannot plot 4.5, 8.5, 4.9. It is suppose if I'm having 500 entries, how my graph is going to look? Vague. That's why we pick up some certain range and we try to find the probability of our outcome with that range. Getting it? Now I'm making sense? What probability density function is? So simply you can say that you cannot directly mark every difference in the data set. So you take the help of probability density so that you can pick up the range. You can find the probability of the outcome with respect to that range and plot the graph. Okay. If you don't do such thing, which means what will happen? It will give you graph somewhat like this.